Hi there, this is Mr. Schnitzius, and this is the last lesson for Activity 26, learning about coordinate proofs. So this lesson is going to be a little bit different. It's still going to involve coordinates, but we're going to find the coordinates of the point that is a given fractional distance along a line segment. And we're also going to find the coordinates of the point that partitions, that basically means divides a line segment into a given ratio. All right, so we're still working along with Maria and Eric in this lesson. Maria tells Eric that she is going to walk from her math classroom to the cafeteria. Before leaving, she depicts her movement on a coordinate plane. Her movement is an example of a directed line segment. So a directed line segment is going to be really important whenever you get into physics. You'll call those vectors. So it's a line segment. It's not only important how long it is, it's also important what direction it's traveling in. Maria indicates the math classroom on the coordinate plane as point M and the cafeteria as point C. Each endpoint of the segment is designated by an ordered pair. Suppose Eric asks Maria to stop at the school's office before heading to the cafeteria. He indicates the location of the office as point O. Suppose the math classroom is located at M, -2, -1, and the cafeteria is at C, 2, 7. The office, point O, is located 1/4 of the distance from point M to point C. So here is a graph where we have points M and C graphed on the grid, and we're going to go ahead and draw the line segment connecting those 2 points. Segment MC, we need to make that just a little bit longer. There we go. So it said that point O is located 1/4 of the distance from point M to point C. That means that we're starting here and we're ending here, right? So would we expect point O to be closer to point M or point C? Well, point M, because halfway along would be the same distance from point M and point C, but we're only going 1/4 of the way, so it should be closer to point M. So the first thing they want us to do is find the slope of segment MC. So the slope is rise over run. That rise over run ratio comes out to be 8/4. Why is that? Well, because from M, we're going from -1 for Y up to 7 for Y. So that's a rise of 8. From M to C, we're going from an X value of -2 to an X value of 2. That's a run of +4. And I want you to notice that we're not reducing this fraction. That'll come out to be important a little bit later on. So what is a good method to determine the coordinates of point O? Then we're going to put that into practice to find the coordinates of point O. So they want us to add 25%. Why 25%? Well, because 25% is 1/4 as a percentage of the run to the coordinate of point M and 25% of the rise to the y coordinate of M. So let's see what work we need to show to get that the answer is -1, 1 for the coordinates of point O. Well, we're starting at point M. The x value of point M is -2, but we're supposed to add 25%, 1/4 of the run. Well, what was the run? The run was 4. Okay, so that's -2 plus, what's 1/4 of 4? That's +1. So -2 plus 1 is how we get -1 for the x value for point O. Then we're going to do the same thing for the y coordinate of point O. Take the y value of our starting point, which is -1, plus 25% of the rise. What was the rise? The rise was 8. So when we evaluate that expression, that's -1 plus 0.25 times 8 is 2. -1 plus 2 is how we get 1. So that gives us the coordinates for point O right there. On some of these easier problems, it might not be terribly difficult to check your answer. Like 1/4 is half of half, right? So where's the midpoint between point M and point C? Well, that's fairly easy to see that that happens at 0, 3. Why is that? Because half of up 8 over 4 is up 4 over 2. Up 4 over 2. Well, what's half of up 4 over 2? It's up 2 over 1. So if you start at point M and go up 2 and over 1, then you find the coordinates for point O. Okay, in which quadrant would we expect point O to be located? Well, let's see. We found that O was going to be at -1, 1. So that is quadrant quadrant 2. If the office were located 3/4 of the way from the math classroom to the cafeteria, would you expect the x or the y coordinate of point O to be negative? Well, then both of those values should be positive, because then it looks like point O would be at the point 1, 5. So since 1/4 is a fairly easy ratio to eyeball, that's half of half, we could have done this one without a terrible amount of work. So let's look at a slightly more involved example. We're going to look at a new pair of coordinates. M this time is going to be at 1, 1, and C is going to be at the point 7, 6. We've graphed those 2 points right here. And this time we want to partition this segment into a ratio of 3:2. Now, the first step in doing this is writing this ratio as a percent. So this 3 comes from the ratio. We don't want to do a part-to-part ratio. We want to do a part-to-whole ratio. So in the denominator, we're going to add the two values from our ratio together. So that gives us 3/5, or 3 over 5 as a percentage is 60%. We want point O to be 60% of the distance from point M to point C. So imagine, let's say the midpoint is about here. It's going to be slightly closer to point C than it is to point M. Now we're going to compute the slope to be able to use the rise and the run. So remember, our slope formula is y2 minus y1 divided by x2 minus x1. So when we work that out, we get a slope of 5 over 6. The rise is 5 and the run is 6. So to put it all together and find the coordinates for point O, we know that points M, O, and C are collinear. So the slope of segment MO needs to be the same as the slope of segment MC. So we're going to find the coordinate, the x coordinate for point O, by multiplying the run of the slope by 60% and adding this value to the x coordinate of point M, where we are starting. So what's our beginning x coordinate? It's 1. We're adding 60% of the run, 6. So that gives us an x coordinate of 4.6. We're going to do the same thing with the y value. Take the y value where we start, add it to 60% of the rise, which is 5. So 1 plus 60% of 5 is 4. And when we plot that point, 4.6, comma 4, we end up with a point that's thankfully closer to point C than it is to point M. That's a way that we can double check to make sure that we solved this correctly. So now we're going to try a couple of examples. The first example that we're going to do is C. Find the coordinates of point V that divides the directed line segment from M to C and partitions the segment into the ratio of 3 to 2. Well, we're going to follow the same steps that we did back here. We're going to convert this ratio into a percentage. So that's going to be 3 over 3 plus 2. That's equal to 3 over 5, which as a percentage would be 60%, but as a decimal would be 0.6. All right, what did we do after that? Well, we found the slope. So the slope is going to be, let's see, always a good idea to label your coordinates x1, y1, x2, y2. So it's going to be y2, 10 minus y1, 4 divided by x2, 5 minus x1, 2. So that's going to be 6 over 3. Again, remember, we are not going to reduce this because we want to use the full rise and the full run. Okay, well, how are we going to find the x value for point V? Well, we're starting at point M, right? So that's starting with an x value of 2. We want to add to that 60% of the run. The run was 3. So that is 2 plus 1.8, which is 3.8. That's the x value for point V. We want to do the same thing with the y value. What's the y value where we're starting at point M? 4. We're going to add to that 60% of the rise. How much is the rise? 6. So that's going to be 4 plus 3.6, which is 7.6. So that tells us that the coordinates for point V are the new x value, comma the new y value, 3.8, comma 7.6. Now, let's double check to make sure that that's reasonable. M is at 2, 4. So here's point M. C is at 5, 10. So we're going to go off the grid just a little bit. So there's point C. There's point M. Let's go ahead and connect those 2 points. Now, if that segment is divided into a ratio of 3 to 2, we would expect to be closer to point C than point M, right? Let's plot the point 3.8, 7.6 and see if that happens. 3.8, 7.6. All right, it's not exactly halfway. It's a little bit closer to point C. I think that is a good way to see that we solved that problem correctly. All right, now it says a line segment is partitioned into the ratio of 5 to 6. Danny states that he needs to multiply the rise and the run of the slope by 83.3%. Do you agree or disagree with this process? Well, if you agreed, you might look at this and think, oh yeah, 5 divided by 6, that's 0.833 repeating. That's 83.3%. But notice that here we didn't just divide 3 by 2. We did 3 divided by the sum of 3 plus 2. That's how we got that percentage that we were going to use. So that's why we have to disagree. He should have instead done 5 over the sum of 5 plus 6, which would give him 5 over 11, or 45.45%. All right. So I want to respect y'all's time. There's 4 videos in this activity. We're going to go for about 10 more minutes and see how much we can do. And whatever we don't get to, I'll go ahead and give y'all the answer so that you can work it out and check it on your own time if you want some extra practice. Number 10 in this lesson practice says point R lies along the directed line segment from Y, -1 -4 to X 7 6, and partitions the segment into the ratio 1 to 4. What is the slope of segment YX and how does this slope compare to the slope of segment YR? Well, to work out the slope, it should come out to be 1.25. Let's see how we get that. Well, we've got the coordinates x1, y1. We've got the coordinates here x2, y2. So if we work out that slope, it's going to be 6 minus -4 over 7 minus -1. So see, this whole activity really is good because it extends your knowledge to some new places, but it's also a good review of just making sure you're not making careless mistakes, right? You don't want to just do 6 minus 4. That's not a positive 4, that's a -4. When you subtract a negative value, that's the same as adding the positive value of that number. So that's the same as 6 plus 4, which is 10. 7 minus -1 is 8. So that's how we get that slope of 5 over 4. How do we know that it's going to be the same? Well, if you look at, for example, this problem that we worked out, or this problem that we worked out, I'm sure you remember your Algebra 1 teacher saying over and over and over again, CROC, constant rate of change. It doesn't matter which 2 points you pick on the line, as long as the points lie on the same line, you're guaranteed to get the same slope. So if we do the slope from M to O, that's the same as the slope from O to C. That's the same as the slope from M to C, as long as M, O, and C are all points that are collinear. So that's why you have to have the same slope. All right, so let's work out one where it has a smaller value from at the beginning of the ratio. Okay, let's work out number 12. So let's see, I guess the first thing that we did was we converted the ratio to a percentage. So that would be 1 over 1 plus 5. That is 1/6, which would be, as a decimal, 0.16 repeating. Now, I'm going to do this one a little bit differently. I'm going to leave this as the fractional form, because since this is a non-repeat or a non-terminating decimal, we're going to lose a little bit of accuracy doing the decimal instead of the fraction. So in a second, we're going to roll with the fraction. So let's find our slope, x1, y1, x2, y2. So that's going to be 10 minus 5 divided by 8 minus 0. So that's going to be a rise over run of 5 over 8. So we're starting at point U. So our x-coordinate is going to be, well, we're starting at 0 plus we're adding in 1/6 of the full run, which is 8. Okay, well, it's nice and easy that we have a 0 here. 1/6 of 8 is 8 over 6, which you can reduce to 4/3, which as a decimal you can write as 1.3 repeating. So that's the x value for point W. Let's do the same thing with the y value. That's going to be the y value where we're starting. U has a y value of 5 plus 1/6 of the whole run, the whole rise, which is 5. So that's going to be 5 plus 5/6, or if we want to round that off to a decimal, that would be 5.83 repeating. So that gives us the x and y value for point W here in number 12. I'm going to leave number 11 for you to work out if you so desire. And it looks like we've got time to do one more from the Tri-B A. I'm going to copy this onto a new page so that we have a bit more work here. Let's do B. Let's work out B now. Okay, so our ratio is 1 to 3, so that's going to be 1 over 1 plus 3. That's 1 over 4. As a percent, that would be 25% of 0.25. Okay, so we need to find the slope. So we've got x1, y1, x2, and y2. So our slope is going to be 4 minus 0 over 6 minus 2. So that's going to be a rise of 4 and a run of 4. So now we want to find the new x-coordinate. So it's from A to R. Our original x value is 2 plus 25% of the original run. Well, this should work out to be pretty easy. 1/4 of 4 is 1, so that's going to give us an x value of 3. We want to do the same thing for the y coordinate now. Where are we starting? We're starting at a y value of 0 plus 25% of the rise, which was 4. We already did 0.25 times 4, that's 1. 0 plus 1 is 1. So that gives us 3, 1. One last hint for you while you're working through point A. What would you call a point that lies half the way along a directed line segment? That is the midpoint. So you can use the midpoint formula also to help you on part A, and you can double check to make sure that you get that answer. Okay, thank you guys for working with me through activity 26. Hope that you all are having a great day. Thank you so much for your hard work. Bye-bye.